If you've ever written end-to-end tests, you know the pain. You spend hours crafting tests for a minor front-end refactor to break everything. So today we're going to architect a solution that fixes this. We'll use a large language model to understand and execute tests based on natural language, creating a resilient test suite with powerful reporting. Let's dive in. Here we're on the Google Cloud Community website. We'll use this as an example to test three scenarios. One is going to be checking all of the links that you see here. The other is inspecting the statistics up on the front page. And then finally, the search capability. So now let's look at a final report and we'll work our way back to how we accomplish that. This is the Allure report that showcases the site that we just inspected. So here we see the test suite. We can drill down into each of the different test stories, and we can then open this up and see each of the individual test cases. So here we see test homepage stats as well as test search. So let's walk through each of these. So here we're testing navigation to individual links. You can see that we've recorded each of the different steps. We are running our browser agent, we're clicking on the link, and so on and so forth. What's really cool here is our AI agent is recording its thoughts as it goes. So you see at each individual step what it's thinking about, how it's navigating, the URL it's starting from, how long the step took, and we're recording a screenshot after each of the actions. Okay, and we can see the test case results, they all passed. Let's take a look at searching. For instance, here we search for BigQuery, Vertex, and then a term that doesn't exist. Again, they all passed. Let's take another look at the main page where you see the environment. These are properties that we record as we go, so we can see what operating system, Python version, browser, etc., which LLM model. These are all customizable, as you will see when I inspect the code, and then grouped by capability. So you can get all of this through a tool called browser use. Browser use allows you to enable AI to control your browser. You can write just a little bit of code, like you see here in the example, where you define an agent, you tell it the task you want it to accomplish, you pass in a large language model, and away it goes. Now there's a little more to it in our situation because we need to record history, and that's where we're pulling the screenshots and the thinking and all of that. Now let's look next at the reporting framework. It's called Allure, and you have several options when it comes to reporting. You could use the standard JUnit XML format to export your test cases. Allure is perfect for our scenario here because it can take screenshots and all kinds of other artifacts along with the test case results in a nicely presented report. So that's why I'm using it here. And I think it looks pretty nice. We also have Pytest, which is a standard framework for testing. You simply will have your different files, typically with a convention of test underscore, whatever the test scenario is, and then you run it with Pytest and you get your output. So let's now look at the architecture of how this all fits together. So as a developer or QA, you're writing some code, you're going to run this Pytest command, then Pytest will launch a series of steps. It's going to validate each of the tasks. That's a custom function that I've written, and you're going to see that in action in our source code. We're now off to the browser use part of the solution. So we have an agent class we defined. I showed you a little bit of that code earlier. What we're going to do is send information about our tasks to the planner, the LLM that we have here, Gemini 2.5 Pro, and it's going to help us return the next action. We're going to execute the command that will go to an embedded browser. It can also use your Chrome browser or other browsers. We'll see how to specify that. We go to the website and then we return that state and pass it back to the agent class. And the cycle continues. Now the agent will have more information about the layout and the task at hand and continues to make decisions. So once this whole process is completed, Allure Pytest which is a plugin for the Pytest framework, will write out to Allure result files, and then we can serve the website that you saw there with the Allure serve command, and that will generate that HTML report for viewing. So that's the overall process. Next, let's go ahead and dive into the code. Okay, so here we are in the test community website.py class. All this is going to do is have a couple different test cases here specified. One that's going to be for testing the homepage stats and another for the searching. So let's look at the homepage stats first. So I'm going to apply a couple decorators here, first for Allure, which helps to categorize the test case. Then I'm using Pytest to mark that this is an asynchronous operation. Then I'm going to parameterize it. In other words, I'm going to run the same code with different combinations and permutations here of the different links and the expected URL segment within those once I've clicked on the next page. Here we're actually going to perform the test itself. So I pass in a task. Click on the link and return the final URL of the page. I will then run this validate task method, which hides a little bit of the complexity of doing this. You're going to see this on the next file. And then just asserts whether it was correct or not. So you see that same formula is being repeated. We categorize the type of tests. We mark this asynchronous. This is general test case code, nothing specific to AI here. What we are doing, again, in each test case is informing the agent of which task it's responsible for and then having it perform the task. Let's now look at the common configuration code here in conf-test.py. So let's now look at the fixtures we have here. So the first one we have is some information about the environment. We're simply going deeper into the Playwright code and extracting out the name of the browser, the version, etc., and so that we can put it into a properties file. That belongs to a fixture called the environment reporter, and this is where we're getting that browser information, the LLM information. We're pulling that all together to eventually create an environment.properties file that is included in those Allure results so that we know which operating system we ran on and so on and so forth. So if you look at the end of the day at this set of properties, you see the OS, the Python version, the browser version, etc. The next fixture, or fixture being an object that's used for testing, we have our LLM. We're defaulting to Gemini 2.5 Pro. We have a browser profile object. This is where things can get interesting, where you can specify the headless mode or not, where you can run without being visible. You also can specify which, say, version of a browser, where on the file system you want to execute it. There's a lot of configuration for the browser. Next, you have a browser session class that pulls in that browser profile. So this is all the setup. So now we're finished with that. Now let's look at that base test class and see what we want to do here. So that validate task class is going to run the following steps. It needs to run a task with the agent, add the base URL, and then check for the assertion. So our task is to go to a link, perform the task, and then run it. Okay, I'm going to actually skip ahead to the run agent task here to really understand what's happening here. This is where now we're getting to the core of that browser use framework. So we are creating a new agent with the task description, the LLM, the browser session, and then running it. There is one extra detail here. We're adding a hook. So at the end of each step, we're going to run this record step method that's going to take our screenshots, the LLM thought process, and so on and so forth. But you see here, to run it overall, you create the agent, you run it, and then it takes the final result and adds that as an Allure artifact and finishes. So now let's look at recording steps and some of the other details we saw here. So here when we record step, this is a hook function. It's going to look at the history, the last action that was taken here, and then it's going to pull information out. What was the action that was taken? what is the model thinking, if that's available, the starting point URL, how long it took, and then the screenshot, which we say was base64 encoded, and put that into the artifacts. So I'll show you how it actually executed. I've already done this here. I ran Pytest, and let's walk through what it does. You see detailed logging, starting up the browser use agent. I ran in headless mode. So you just see the text here. You're seeing token use in the model, input and output tokens. And we can then see the thinking, the memory, what its next goal is, what step it's on, so on and so forth. I'm going to just scroll to the bottom here. So we see that our task finished, all 8 passed, about 6 minutes to run from end to end. Then what I did is, after I generated these artifacts, I ran the Allure server here. So you see here, Allure serve, Allure results. So let's now take a look at the code that can help you do this. It's all available on GitHub, and it's here in this agentic test automation sample. So you see, again, the tech stack we use: browser use, Pytest, and Allure reporting. The key features, I provide a little bit of information on that common file that we just walked through and how you could write your own test cases, a little bit about how to do it yourself, and setting up your virtual environment and running the tests. That's all it takes. The code's all on GitHub, linked in the description. Clone it, experiment with it, and rethink what's possible with test automation. If you found this technical deep dive interesting, hit that like and subscribe. Hope to see you on the next one. Thanks for watching.